Hi, welcome back to Mathematical Maths. So in today's video we're going to do some integration by inspection and integration by substitution. And just in the same as the last video, we're going to have my another student joining us.
Ooh, hello.
So he's going to kind of be the same thing as last time. He's going to be looking at different things I say, and if there's any questions that you have, he'll probably have.
Trust me, I have a lot of questions.
Yeah, so anyway, let's get started. So we're going to start off with the integral of 12, 3x to the 5th to the power of 3 dx. So, do you have any idea what to do here?
Well, I think what you first do is you define your u. You can make this u.
Oh, well, just by inspection. And then
Oh
we'll do
yeah,
substitution.
yes, this is by inspection, I think. So you make u.
Well, no, not the u part.
Huh?
Not the u part, just like by looking at it.
Oh, just by looking at it?
Yeah.
I would assume that you bring this down, you multiply it times 3, and then you add, you add 1 and then you divide by it. I was thinking of differentiation.
Okay.
So I think what you would do would be y equals to 12 over 4, 3 times 3x plus 5 raised to power 4 plus c.
Almost. The last thing you had to do was divide by the differential inside.
Oh, so we divide all this by the differential of this,
Except
and that's 3. So it would be times 3 on the bottom here.
Exactly. Yeah.
Okay, so then it would then be equal to, sorry for my bad handwriting, people, 12 divided by 4 times 3 would 12 3x plus 5 raised to power 4 plus c. Y equals 12 times 12 cancels out to be 1. 3x plus 5 raised to power 4 plus c.
Exactly. And do you know why you divided by the differentials inside?
The quotient? No, chain rule.
Exactly.
Opposite of chain rule.
Because what happens is when we have this function here, we bring the 4 to the front, but we also need to multiply it by the inside parts. And what we're doing, instead of multiplying, we're just dividing, and that'll get rid of that bottom part. But yeah, excellent job.
Yeah.
So what we're going to do next is the integral of sine of pi divided by 2x. Okay? So this is the exact same thing as the chain rule, but we're just going to do the opposite. So we take the integral of the outside, then we divide by the integral of the differential of the inside. Okay? So do you know what the integral of sine is?
Negative cosine.
Yeah. So we have minus cosine, and then the inside always stays the same anytime you have a trigonometric function.
Pi root 2.
But then all we have to do is divide by the differential of the inside. Okay? And do you know what the differential of the inside is?
The differential of the inside would be just pi over 2.
Exactly. So it's going to be pi divided by 2, and that just simplifies to minus 2 cosine of pi divided by 2x divided by pi plus c. And that's that integral. Now we'll do one more integral, and then I'll show you an even easier way where you don't have to because sometimes you might be working through this and you might not notice things straight away, but we're going to do another thing called integration by substitution. This will hopefully make a lot of things easier. But anyway, to the last example. So we are going to have x to the power of e to the power of x squared plus 3 dx. Yeah. Okay, so do you want to have both this or?
By inspection, right?
Yes, by inspection.
Let's see what I can do. So I believe the first thing you do is you add 1 to this.
Okay, the only thing is, remember, when you're integrating or differentiating anything to the power of e, that always stays the same.
Oh, so it's going to be...
So in this example, we know we're going to have this part here.
So write that, x squared plus 3.
Yeah.
And then now we differentiate this,
And then
we divide by it.
exactly, yeah.
So it would be differentiation, right?
Yeah.
So it would be just x, 2x.
Exactly.
2x. So
So you can
all
divide
this
by
over 2x.
Yep.
What about this x?
Yeah, that stays there.
Oh, it just stays there?
Yep.
You don't do anything to it? Why and why not?
And the reason why is because as we move forward in this function, these will cancel out. And the thing is, anytime something's multiplied, we consider this to be part of the same function.
Oh, okay. So this is plus c.
Yep. But this can simplify.
One of it will cancel out, so it'll be e x squared plus 3 plus c all over x, or we can just do x raised to power -1, right?
Yeah. The only thing is, it's not, the c isn't part of the divided by
Oh.
part. But yeah, that part's fine. The second part's fine. Okay, well, now we're going to clean off the whiteboard and we're going to get some more questions, and then we're going to show you what integration by substitution is. So, we'll be right back.
Back at it again. Let's do some more math.
Yeah, let's do some more math. Now we're going to do integration by substitution, and these are the examples we're going to do. So, a lot of times, last time, you just had to have a look at it and be like, oh, maybe that works, maybe that doesn't work. Except this time what we're going to do is we're just going to replace some of the terms with u. So we'll take this first one here. Integral of 6x root, or in this case we'll just do 6x multiplied by 3x squared plus 4 to the 1/2 power. Okay? So what we can do is we can replace this inside term with a u. Okay? So 3x squared plus 4 equals u. Now, what the aim of this is to try and cancel out some of the terms, and this basically means we're left with a simplified version. So we're going to first of all take the differential of this, so du over dx. So we're going to have du divided by dx, and that's going to be equal to 6x. Now, what we're going to do is normally the differential, like dy over dx or du over dx, isn't a fraction, but in this case we're going to say it is. Okay? For no particular reason. So we can rearrange this, and to get rid of this dx, we can say du divided by 6x equals dx. Okay?
So
exactly. So what we can do is we can replace this dx with this term here. So we can have the integral of 6x multiplied by u to the 1/2, because remember, we replaced this term here with the u multiplied, and then we replace the dx with du divided by 6x. So in this case, what happens is these 6x's cancel out, and we're left with the differential of u to the power of 1/2. And this is just like regular integration. So do you want to do this part?
Yeah. So basically what you do is you add 1 to the top. So we're gonna add 2 over 2 because 2 over 2 equals to 1, and then you divide by whatever you get. So adding 1, it would give you 3 over 2, and then you divide it by 3 over 2. So dividing by 3 over 2 is basically multiplying by 2 over 3. So you get y equals to 2 over 3 of u raised to power 3 over 2 plus, because du plus c.
Exactly. Now, do you want to just substitute in what u is?
So after that, you substitute what u is, and you get y equals to 2 over 3. U is equal to 3x squared plus 4, all raised to power 3 over 2 plus c.
Okay, right, good job. And that's exactly what it is. Now, it may seem like there's a lot more steps, but that will make it easier just to see what's happening here. Because instead of saying, okay, we just jump from here, this equals that, that equals that, we're just saying, okay, well, we substitute this in here, we can move this around, different things like that. So hopefully this has helped. So now we're going to do the next one. now we're going to take the integral of this. Now some of you may be able to see that and just be like, oh, it's da da da. But what we are going to do is we're going to do this by substitution.
Substitution, yes.
Yes. Because, well, I'll tell you what, in this case we'll show the substitution and we'll also show just the inspection. So if I was to do the inspection method, what we could say is we know anytime we differentiate sine, we always get cosine. But then we also need to multiply by the differential of the inside. So we can say sine multiplied by x to the third divided by the differential of that, which is 3x squared, those cancel out. So in this case, you could have just seen that. But if you didn't, or if you're in an exam or whatever, and you can't really see what's going on, what you're going to do is integration by substitution. Now, the hardest part of substitution is trying to factor what term you're going to use. So in this case, we're going to say u equals x to the third, okay? So we can rewrite this as the integral of 3x squared cosine of u, okay? Now what we can do is dx. The same thing as last time, we're going to make this in terms of du. So we're going to have u equals x cubed. I'll write this over here. U equals x cubed. Differential of this, du divided by dx equals 2x cubed. So then what happens, we rearrange this, we get du divided by 2x cubed equals dx. Now what happens, we're going to substitute this in here. So we have all over dx 3x squared, that's supposed to be a 3 there, and this multiplied by du. So we know these terms here cancel out and these terms here cancel out. So we are left with the integral of cosine of u with respect to du. And we always want to have it in terms of du. Because if, for example, we still had an x in there, that wouldn't be helpful because we can't integrate with more than 2 unknowns, okay, or 2 variables. Because if that was just an integer, like 5 or 6, we can just integrate it and we know what to do. But because there's multiple values for x on the xy plane, and u is related to x because of the variable term, we have to make it in terms of du or dx. So now it's just regular integration, and do you want to do this?
Yes, sir. So if you want to differentiate sine of u, you get the cos of u. So to integrate it, since it's the opposite, all you have to do is just do y equals to sine of u plus c.
But the final question we're going to do is this question here. And we'll write this out. So you have 2 sine of 2x per e to the power of cosine 2x. Okay? So remember, anytime we have something to the power of e, that's always going to stay there after the integration. So we know we're going to have something to the power of e. Okay? So do you want to have a go at this? Or
I think do we make u cos of 2x?
Yes.
Yes, I do.
And a key thing to see is anytime we differentiated, we always brought this term here to the front. And he could see that because we're taking the integration, we just moved that back. But anyway, after.
So u equals to cos of 2x. Du dx equals to well, first we know that sine is the cos is the derivative of sine, so this never changes to x. But then we bring the derivative of this to the front, so that's going to be 2 sine 2x. So now we're trying to find what dx equals, so we can put it, dx is here. So we put it in terms of dx. So it's going to be dx equals to du over 2 sine 2x. So then we can now plug in things back into this equation. So we'd get, my bad, I'm very bad at drawing the integration sign. So we get 2 sine 2x e raised to power u times du all over 2 sine 2x. Now what you notice is that this and this are the same thing. So you just draw a nice slash through. Bam, bam. And then you are left with e raised to power u times du. That's basically it. That's your you've gone from here to there. And then what you do to eliminate the integration sign is the differentiation of e will always to the power is always e to the power, but you bring out the differentiation to the top. So this time you're going to divide by it. So you differentiate e is going to be e raised to power u. The differentiation of u would just be 1. So we do over 1, which is going to be eu, and then du is just going to be c. So that's it. And then now we plug in u. You have to remember to do that. So remember that u is cos 2x, y equals to this. So y equals to e raised to power cos of 2x plus c. And that is your answer.
Yeah, so excellent job, excellent job. And as you can see, this is a perfect way of working through it to substitute in u afterwards. So yeah, here's the board. If you have any questions, don't forget to subscribe, like, comment, hit that notification button, and stay mathematical. We'll see you in the next video. Bye.